Hi, welcome to the second video on factoring. This one is going to concentrate on trinomials. Okay, so just a quick review, what is a trinomial? So a trinomial is a mathematical expression or polynomial that has three terms. So for example, here we go, three terms. Okay, this is a trinomial, and this is called a simple trinomial because the coefficient of the x squared is 1. Okay, we don't write it, but it's there. It's a 1. In a few minutes, we'll talk about complex trinomial, where you'll see a number there, which is not equal to 1. Okay, so how did we learn to factor this last year? So last year we said if you have a simple trinomial, what you do, it's actually very simple. You can do it in one step. You put the x in both brackets, and then what we do is we find two numbers that multiply to positive 12 and add to negative 7. So, okay, what goes into 12? Well, you can have 1 times 12, 2 times 6, 3 times 4. That's probably it. So can you find something that adds to negative 7? Well, probably these two, but they'll be positive 7. So if we turn them both negative, then we have a product of negative 12 and a sum of negative 7. Sorry, we have a product of positive 12 and a sum of negative 7. So you take these two numbers and you put them into the brackets, just like that, and it's done. Okay, so that is simple trinomial. And that was the easy one, so now we're going to move down to complex trinomial. Okay, so here's an example. 2x squared plus 7x plus 3. Okay, we're going to factor this. So it's not as simple as coming up with the two numbers and putting them in the brackets. There's actually several ways of factoring this. So I'm going to show you 3 ways, and I'm going to let you choose whatever is best for you, whatever you like best. You just need to be accurate and you need to be quick with it. So other than that, it doesn't matter to me what method you use. So we're going to take this complex trinomial. I'm going to start with the method of decomposition. So depending on who your teacher was last year, they may have had a preference. So maybe you haven't seen all of these methods, and that's perfectly fine. You're just going to pick something that you like. Okay, so the method of decomposition says, I'm going to try to decompose this middle term, break it up into 2 parts. And the way we do it, we do the following. We say, take the 2 and take the 3, multiply them, we get 6. So we need to try to find two numbers that multiply to 6 and add to 7. So what two numbers will multiply to 6 and add to 7? Well, they will be 6 and 1. So I'm going to rewrite this expression as 2x squared, and the 7x, I'm going to decompose it into 2 parts, 6x and 1x, based on those two numbers I found. Okay, and then write the 3. And now I have an expression that has 4 terms, and we already saw previously, when you have 4 terms, you can use factoring by grouping. So I'm going to group these 2 pieces. And for the first piece, I'm going to factor it, so I will take out a common factor. I can take out a 2, I can take out an x, and I have 2x times x plus 3. And for the second piece, can't really take anything out, but I do have this x plus 3. If you want, you can put a 1 there, just so that this piece here looks the same as this one here, with the x plus 3 in the brackets. Of course, it doesn't make any difference if you do that or not. Okay. Now you look at the 2 parts and you say, what's in common? Oh, I have a bracket with x plus 3 in it. So that becomes the common factor. And what goes inside is, well, if I take this part here divided by x plus 3, I'm left with just 2x. And if I take this part here divided by x plus 3, I'm left with a 1. And now I'm factored. And that's done. Okay, that is the method of decomposition. So the idea is this. The idea is if you have, so complex trinomial is ax squared plus bx plus c. Okay, that is the general form of a complex trinomial. You have to find two numbers that multiply to AC and add to B. That's your start, and then you decompose the middle term. So first you find your two numbers, then you decompose the middle term, and then you factor by grouping. And that is decomposition. Okay, I'm going to show you another method. So if that was okay, please try any of the ones in the booklet. Just try and see if you can follow that method. Okay, here's another method called the crisscross method. And there are so many that maybe crisscross method has other names as well, but this is how I learned it. So I learned the crisscross method. Here's our trinomial, same one. Okay. What you do with the crisscross method is you take the first coefficient, the 2, and you factor it into two numbers. So I can write 2 as 2 times 1. Okay, and you do the same thing with the 3. I can write 3 as 3 times 1. And then what we do is we multiply crisscross diagonally. And we try to make the sum of the two products equal to 7. So what does that mean? It means if I go 2 times 1, I get 2. 1 times 3, I get 3. If I add that product 2 plus that product of 3, I get 5, which is not the same as the middle term. So I know that this 3 and 1 or this 2 and 1 is not correct. Okay, but there's other ways I can write either one of these. For example, instead of 3 and 1, I can make it 1 and 3. Okay, so the crisscross method requires possibly some trial and error. Now look what happens now. I have 2 times 3, which is 6, and 1 times 1, which is 1. You add them up, you do get 7, which means this is going to be the correct combination. And how do I write it now as in factored form? Well, I open my two brackets. In the first bracket, I'm going to, well, basically we're reading straight across. So the first bracket is going to have the 2, it's going to have the x, read straight across, you have a positive 1 there. And the second bracket, here's the coefficient of the x, it's a 1, so I'm not going to write it. Read straight across, plus 3. And there we have it factored. You see it's the same factorization as the other method. Good thing, because it should have the same answer. Okay, and so this is also factored. I'll do another example with crisscross with numbers that are a little bit bigger. So I'll go 6x squared minus 5x minus 6. Alright, now remember with crisscross, what we're trying to do is we're trying to write the 6 as product of two numbers. So let's say 2 and 3. I can write this 6 as any product of two numbers. So I can do 2 and 3 again if I want. I mean, here we go, 2 and 3. But now if I multiply crisscross, I get a 6 and a 6. That does not add up to negative 5. So I gotta try other things. So how about I try 6 and 1? Also possible. But this will be 2 and 18, and I can't make 2 and 18 add up to negative 5. So I could change these two, I could change these two, just really play around with different possibilities. Let's try 3 and 2. And now this product is 9 and this product is 4, which is very promising because from 9 and 4 we can get negative 5 if we turn the 9 negative. So if I put a negative here, this will work well because it really was a negative 6, which means one of these two has to be negative for the product to be negative 6. And now we have 3 times negative 3, which is negative 9, 2 times 2, which is positive 4, and that adds up to negative 5. So now to write this out, I write my two brackets, and then I got the coefficient is 2, and I write my x, read straight across, minus 3, and 3x plus 2. Right, and there we have it. There's one other method I wanted to show you, which is called trial and error. And so similar to the crisscross method, but with no writing. So it looks like this. For trial and error, really, you need to be a master of your times tables. Sorry about that. So here we go, trial and error. we're going to do the two brackets right away. And we're just going to experiment with numbers and put them in. What times what could equal 6x squared? Well, I could do 6x times x. I could do 2x times 3x, or reverse them. So let's try 2x and 3x. I write them right in the brackets. And how many ways could I break down 6? Because when you expand, this term, the last term here and the last term here multiplied will give us the last term in the expanded form. So this number times this number has to be negative 6. How many different ways can I do that? Well, I could do 6 and 1, or I could do 2 and 3, or I can do 3 and 2, or I could do 1 and 6. So you see it's the same thought process as for the crisscross, except I'm not writing it. So let's try. So let me try 1 and 6. Well, when I expand this, here's my 6x squared, that's going to work. Here's my 1 and 6, that's going to work. But now we have to get the middle term. To get the middle term, I'll have 2x times 6, which is 12x, and then 1 times 3x, which is 3x. There's no way to get negative 5 from 12 and 3, even if one of them is made negative. So I know that that's not the right combination. Let's try another one. Oh, I can try 2 and 3. Okay, so we know the last term will work, the first term will work. We're checking the middle terms. So 2x times 3 is 6x, and 2 times 3x again is 6x. So 6x and 6x will not make negative 5. Another way to know that this particular combination will not work is because if this was the right combination, then this first factor would have a common factor of 2. But the original question did not have a common factor of 2. So we know that that's impossible. Similarly, the second bracket would have a common factor of 3, but the original question did not have a common factor of 3. So you know this can't be right. So it's going to have to be a combination of things where there's no common factor anywhere, because the original question didn't have common factors. So the only one, I think, is going to be 3 and 2. So let's test it. 2x times 2 is 4x. 3 times 3x is 9x. Can we get negative 5 from 4 and 9? Sure, as long as the 9 is made negative. So I'm going to make this one negative because that'll give me my 3 times 3x. And this one will be positive. And now it's factored. I will just compare. It's the same answer as we got with the crisscross method. Okay, so you pick and choose. There are other teachers had other methods they taught, not one of these 3. You are very welcome to teach me any method that you know that I don't know. I know others, but I don't want to confuse people too much. The key is be quick, be accurate, choose the one you're most comfortable with, and I'm good with that. Okay, the last thing I just wanted to mention is a perfect square trinomial. Here's an example of a perfect square trinomial. Not to be confused with the difference of squares. The difference of squares has only 2 terms. So perfect square trinomial. What makes this a perfect square? It means that if I factor this, I can write it as some binomial squared. Okay, so since this is a simple trinomial, I can factor it. I need 2 numbers that multiply to positive 9 and add to negative 6. Those 2 numbers happen to be negative 3 and negative 3. So both brackets are going to be the same. And so this can be written as x minus 3 squared. There's no difference. You can write it this way or this way, but that's just to show you that this is a perfect square trinomial. How do you recognize a perfect square trinomial? Well, the middle term, so remember it's x squared plus bx plus c, because this one is simple. The middle term, you get the middle term by taking, rewind. Okay, you get the last term by taking the middle term, dividing it by 2, and then squaring that answer. That gives you the last term. Okay, so if somebody gives you this and they ask you, is that a perfect square trinomial? Well, let's test it. If I take negative 6 divide that by 2 and square it, will I get positive 9? And the answer is yes, I will. So it is a perfect square trinomial. Here's another example, and then we'll be done with this video. Here's a complex trinomial that's a perfect square. Okay, and the question is, how do you know that? How do you know that it's a perfect square trinomial? Oops, sorry, I left my X. Okay, so the way that you know that is that the middle term, if you divide it by 2 and you square it, you get AC. So I'm referring to ax squared plus bx plus c. So not simple, it's complex, there is an a. If you take the middle term and divide it by 2, you get 6. 6 does equal to 4 times 9. So therefore it is a perfect square trinomial. Okay, so that's it for factoring. Now, if you look on my website, you will see some additional factoring practice that is much more challenging than these basic ones, and the answers will be posted too. I really encourage everybody to try the challenge ones. You must be very well practiced with factoring in order to go forward. Okay, so once again, if factoring is a problem, if you're not very clear, if you're having difficulty not getting them right or it's taking too long, please come and see me. Don't wait. Come and see me and we'll work together, or come to Math Extra Help, or work with your classmates, or all of those things. Okay, good luck. Thanks for watching.